Welcome to the course on data science for undergraduates. I'm Abhinandan H. Patil, your instructor for today and for this whole course. So I would like to call myself as an engineer, and these are my credentials. As you see, I hold MTech and informal PhD. I hold ISTQB CITAL TM, CSM. I am a senior member of IEEE. I also possess PMI, PMP, UGC NET in 2012, and Indian Achiever in year 2021 and 22. So you can get my academic and research profile from this link over here. Briefly, I possess around 18.5 years of experience, out of which 11.5 years was in industry and 7 years was in research. I have possess experience in both software development and testing. I'm well versed with transformative latest digital transformative technologies like cloud, data science, machine learning, deep learning, Internet of Things, latest wireless network technologies, and blockchain. I have not done anything in blockchain hands-on, but concepts are very strong. So blockchain concepts wise, I know. So these are various technologies in which I'm active. So that's brief description about this is my industrial profile and this is my blog. Now talking about today's course. This course is basically for undergraduates who are pursuing data science as one of the subjects in their course curriculum. Uh, Specifically, the course is tailored for syllabus of one university in India, where data science from scratch, first principles with Python orally book is prescribed as a textbook. So all the content will be from data science from scratch, first principles with Python, and myself, the instructor, I'll not deviate from the prescribed textbook. Just to stick to the course curriculum, I'll not deviate from prescribed textbook. Only barring few cases where I'll add additional material to facilitate the understanding. And what do we mean by first principles? What we mean by first principles is, as far as possible, we will not make use of libraries as such. Everything we will code, from scratch. That's first principle in spirit. Uh, and then certain level of Python understanding is assumed. You can take Python course from myself on Udemy, or from any other sources. As long as you know Python basics, we are good to go. The instructor makes generous use of MIT license of Joel Gress, that's the author of this book. The author has given the code with MIT license. We will take the GitHub code of Joel Gress and analyze the code to understand the subject. For all the lecture, video downloadable resources are given at the end of a section. So whatever code I demonstrate, I'll give it in the downloadable section, just in case you want to modify or enhance them. Although this course is prepared for the mentioned university, this should help anybody who is pursuing data science as one of the courses. I have made every attempt to keep the content at basic level. At the same time, I will not keep it very basic to prevent other students from losing interest. So I'll take the middle path. I'll not go very basic, nor I'll go very fast. And wherever possible, standard documentations we are referring. This is to inculcate good practice in students. Okay, and I recommend you, the students, not to rush through the course. At the end of every section, as far as possible, try out the code that is given in the section yourself. Understand it, enhance it, modify it, and get hands on. Finally, I wish you good luck for your study, and I hope the learning will be enjoyable for you. Thank you. Welcome back. This section is on Anaconda VS Code, and IPython notebooks. So if you go to Anaconda products distribution, you should see Anaconda distribution for download. You have to download the appropriate version of Anaconda. It could be for Windows, Mac, or Linux, depending upon what platform you are making use of. So at present, it is 621 MB in size, and Python version is still 3.9. Of course, 3.11 is released, but Anaconda distribution is at 3.9.13 to be precise. You have to download, and it's Anaconda is environment. You can make use of all these in Anaconda. I'll cover them one by one, but like with Anaconda is a default environment for data science work. Okay, so scikit-learn, SciPy, TensorFlow, PyTorch, okay, Matplotlib, everything you can have in a Anaconda environment. So if you see here, like I have two environments. One is for base and one is for TensorFlow. So if you go to a navigator environments and if you click on base, you can see everything that is installed over here. Now let's say if we are interested in 441 packages are already available. Let's say we are interested in interactive Python. Okay, I'll just say IPy. Okay, so you can see IPython, IPyKernel, everything is there. So this is a way you can navigate and find the interested package within the environment. Next is VS Code. This is how the VS Code environment looks like. You have to get the latest VS Code binary, download it, install it, and then appropriate extensions you need to download. Appropriate extensions you just need to download. Okay, let's say since we are writing everything in Python. Okay, let's say Python. The moment you type Python, okay, so like here you will see Microsoft with the name Microsoft. This is the one you need to install. This will install everything that is needed along with the Python. Okay, and needed to work along with Python. Okay, so that is the thing. Next is yeah, let's talk about IPython notebook. IPython notebook basically looks something like this. Okay, so here, as you see, since we are taking everything from Joel Grass's book, we are attributing the work derived from Joel Grass. Just you have to just press on, go on pressing like this. Whether when you want to insert a code, you just need to say code. When you want to insert a markdown section, you need to insert a markdown section. This is a markdown. This is a code. Okay, so you just need to go on inserting whatever you want. And why we are sticking to IPython notebooks in this case is because everything you will get to see in one consolidated place like this. Okay, if there are, you will appreciate it here. See, if there are any graphs over there in the IPython notebook, all of them will show up here. So in one consolidated places, you will get all the information. So that is the advantage of using IPython notebook. So in this section, we covered Anaconda, VS Code, and IPython notebook. We will be making use of them extensively in all the subsequent assignments. Thank you. Welcome to linear algebra chapter. Linear algebra, statistics, probability, and differential calculus are the building blocks of data science. So first, that's why linear algebra, statistics, and probability are covered in this book. So we import list, tuple, and callable from typing. Like if you are interested in theory of typing, documentation and library typing, you can get it from here. Yeah, you can get it from this particular documentation over here. 3.9.14 is a version that you can refer to if you are using 3.9.13 the way I'm using it. And then what we do is we define a vector as a list of floats. Okay, and let's say two lists are defined like this, right? Like height, weight, age, and grades, right? The way to these are not used, I believe, but it's there in the book. It is carried over. Like the way we add two vectors, right? The way we add two vectors, like let's say 1, 2, 3, one vector, 4, 5, 6, another vector. Ideally, we should add x and x, that is 5, 1 and 4, 2 and 5, 7, 3 and 6, 9, right? We want it like this. The way we do it is, v is one vector, w is another vector. If length of v is not equal to length of w, we should, there itself, we should come out of this function. If they are both same, what we do is, first for v underscore I, w underscore I in zip vw. So first what we do is, we construct a zip with corresponding elements of vector v and w. So when these two vectors are passed, 1, 2, 3, and 4, 5, 6 respectively, right? The zip operation will return 1, 4, 2, 5, and 3, 6. The way what we do is we sum them. So like 1 plus 4 is 5, 2 plus 5 is 7, 3 and 6 is 9. Okay, so this is for adding vectors. Next is, you may ask, right, what is this colon vector, and arrow vector? What if I drop them? You can very well drop colon vector, and arrow vector. If you do add VW also, you'll get the same value over here. Okay, so I think this was done in PEP 3107, PEP 484. Okay, so this additional annotations, right, to the functions were done in PEP 3107 and PEP 484. You can refer to additional documentation. I think it is enforced 3.5 onwards. Okay, Python 3.5 onwards. Okay, so next is subtract, same logic, but in this case we will be subtracting x from x, y from y, z from z. Okay, so if somebody passes 5, 7, 9, and 4, 5, 6, we will get 1. 5 minus 4 is 1, 7 minus 5 is 2, 9 minus 6 is 3. This is for subtract. And vector sum, right? Vector sum, the way, if we saw only two vectors, if somebody passes list of vectors, right? List of vectors, more than two, 1, 2, 3, 4, and 5, 6, right? We should sum corresponding 1, 3, 5, that is 9, 2, 4 is 6, 6 plus 6 is 12. And the way we do it is, first, whether assert vectors, no vectors provided. If no vectors are provided, if it is empty, we say no vectors are provided. Otherwise, num of elements is equal to length of vector 0. So when we pick vector 0, it will return value 2. The way we do it is, we make sure all of them are of same size, right? All of them are of same size. If list contains three three vectors, all of them should be of same size. All assert all length of v is equal to number of elements, right? Number of elements we picked as 2 in this case for this data. For v in it starts from here. For v in vectors, right, length of v is equal to number of elements, and this number of elements we would have picked from the first vector, right? So it will check whether all of them contain 2 for this kind of invocation. And the way we do is return for vector in vectors, right? A vector in vectors would give us a value 1, 2, 3, 4, 5, 6. Sum of vector I, right? Sum of vector I. So vector I, when you sum, right, it will return 1 plus 3 plus 5, that is 9. And but before that, for I in range number of elements, right, range in number of elements. That will give us what? That will give us value 2. Okay, like for I in range, this will give 0 and 1. So we go on summing twice. How? Twice, like 1 plus 3 plus 5, 2 plus 4 plus 6, twice, right? Once we sum 1, 3 and 5. Second time we sum 2, 4 and 6, right? That is how it is, 9 and 12. A scalar multiply, when scalar multiply is called, right, we take one float and one vector. If somebody asks us to multiply three to vector 1 to 3, we should get 3, 6 and 9. Okay, so it is each element, right? Like the way it happens is for v underscore I in v is what actually? V is 1 to 3, right? C star v underscore I, C is like in this case 3, so we multiply 3 with 1, 3 with 2, 3 with 3, and we return the value. Vector mean, if you look at vector mean, the way it happens is when somebody asks us to give vector mean of 2, 4, 6, 8, 10, 2. First, what we do is length of vectors, right? That will give us n, and then scalar multiply of like 1 by 3, okay, and vector sum of these two, okay, these three, vector sum of these three is 2 plus 6 is 8, 8 plus 10 is 18, 18 divided by 3 is 6, okay, 4 plus 8 is 12, 12 plus 12 is 24, 24 divided by 3 is 8 again. And next let us look at dot product. Dot product is if two vectors are given, we first ensure that both of them are same length, and then for v underscore I, w underscore I in zip vw, okay, vw is what actually in this case it is 1 4 comma 2 5 comma 3 6, right? So we go on multiplying each one of them, first 4, then 10, then 18, right? So it is 4 plus 10 14, 14 plus 18 32, right? We have to multiply the corresponding x, y, z and sum them, okay? So that is 32. Sum of squares, if somebody is interested in sum of squares, sum of squares of 1 to 3 is passed, let's say, right, 1 to 3 is passed, then it is 1 plus 4 plus 9, that is 14. If 2 4 6 is passed, right, what we are doing is dot with self, dot of vv, but dot is defined over here. So it is dot with self, right? It is 4 plus 16 20 plus 6 36 56. Okay. Next is magnitude. The way magnitude is defined is somebody may invoke a magnitude 4 5. When magnitude 4 5 is invoked, right? First, what we do is sum of squares of v, right? It will be 16 plus uh, 16 plus 25, okay, that will be 41, 41 square root, okay. In this case it's very straightforward, 9 plus 16 25 5, okay, this will be 5. You can take a Pythagorean triplets, it will be a whole value. Square distance between two vectors, right? Sum of squares, first we subtract, right, and then we invoke sum of squares, right, sum of squares. Okay, this is square distance. And if somebody is interested in distance, right, first we get square distance and then square root on it, so if some distance between 2.65 and 3.1, if we are interested in, like when we say distance 6.5 and 3.1, so it becomes 6 minus 3 3, 5 minus 1 4, so it is 9 plus 16, 25, 25 square root 5. Now, what is matrix? Matrix is lists of lists, right? So you can visualize this as one list, this as second list. So it is list of list. B is again a list of lists, right? And then a shape, if somebody is interested, right, the way we should return is when this is passed, we should get value 2, comma 3. If this is passed, we should get a 3, comma 2. The way it is implemented is over here, okay? So when a shape of 1, 2, 3, comma 4, 5, 6, comma 1, 2, 3 is passed, right? This will return a tuple, like 3 comma 3 to return. Number of rows is equal to length of A, okay? Number of rows is length of A. In this case, length of A is 3, right? 1, 2, 3, that value gets printed here. And that value comes as number of rows, and number of columns is equal to any one we pick, right? First one we pick, that is 1, 2, 3. If A, else 0, meaning if this row should exist, okay, number of columns will be equal to first row we pick and then length of that is 3. Okay, next, get row. If somebody is interested in a particular row, right, the way we do it is from B we are interested in 1. B is defined as this. So we are interested in B1, first row, right? First row. The way that we do is return A of I, right? Here, this is 0, this is 1. So 3, 4 should get printed. 3 and 4 is getting printed. Get column, what we do is, in this case, we are interested in 2, 4, 6, and this is the implementation. The way it happens is for A of A underscore I in A, right? A underscore I in A of I J, right? Here, if you see, J is 1, right? J is 1 because we have passed this value as 1 over here. So the first column, that is 2, 4, 6, gets printed in a row format over here. Next is next function is make matrix, right? Make matrix takes 3 parameters. One is int, another one int, and then a callable function. And the way we invoke it is make matrix 2 comma 2 lambda I comma j is equal defined as I plus j. Okay. So like when 2 comma 2, ideally there will be 4 elements in it, and then I comma j, first value will be 0, second will be 0 plus 1 1, and 1 plus 0 1, 1 plus 1 2, right? So this, the way it is implemented is for j in number of columns, right? For I in number of rows, right? This will give 4 values, and then like for those 4 things, right? Entry function ij is defined as I plus j, right? So it will be 0 plus 0, that is 0, 0 plus 1 is 1, okay, 1 plus 0 1, 1 plus 1 2. Now, the way to do for identity matrix is one where all the diagonal elements are 1, right? All the elements are 1. The way we implement it is we call make matrix n comma n because it is a same, right? It's a square matrix, right? Square matrix. So like when somebody says identity matrix 5, like this will be 5 comma 5, and in this case, right, the lambda is defined as ij is 1, okay, ij is 1 if I is equal to j, meaning if it is a diagonal element, else 0, right? So this is the way it gets initialized. This is a redundant data over here, ignore it. Now friendships, right? Again, this is coming back over here. 0 is friend of 1, 0 is friend of 2. From this, right, we can construct a friend matrix, right? In this case, what we are putting is 0 is friend of 1, so this is put 1. 0 is friend of 2, so we put 1. So this is a way already pre-constructed friend matrix is there. If we want to assert whether 2 is friend of 0, then all we need to do is friend matrix. We need to pass 0 and 2. If it is 1, we say they are friends. Otherwise, if 0 and 8, if you check, right, 0 and 8, 0 and 8, right? 0 and 8, this is 0, so they are not friends. Now, what we do is, what we do is, for I is friend, right? I enumerate, right? Enumerate function, it returns index and the value, right? So when we say enumerate over 5, in this case it will be this row over here, okay, 0 1 2 3 4 and 5, right? Enumerate, right? When you say enumerate, friends of 5, we enumerate and then we print, I'm sorry, this over here, enumerate 5, okay, we enumerate over there, and then if it is 1, in that case only we print the index, and otherwise we don't, right? So it is 4, 6 and 7. So we are printing 4, 6 and 7. So this enumerate, if you see the documentation, this will return an index and a value. What is index in all of these cases? It is, in this case it is 0, index is 1, index is 2, index is 3, index is 4, 5, 6, 7, 8 and 9. Also we return the value, actual value 1, okay. So this value is picked by is friend, right? So like for this value, is friend is true, so we print I and this is friend, right? I value, index value. So index value gets printed as 4, index 6 and 7. So that is the value over here. Welcome back. So in this class, we will be revisiting lists, dictionaries and tuples, to reassess our Python's knowledge. So one more thing is we make use of extensively collections library, from collections to be specific counter. Counter is a type of a dictionary, and then we also make use of default dictionary. So first we create 10 users, right, with their names. So users is a data structure, which is a list where every item is two dictionary items, right? So this is one item, dictionary item, this is another dictionary item. And we also create a list of tuples. We also create a list of tuples, where we maintain 0 is friends with who? 0 is friends with 1, 0 is friends with 2. We print the users to check whether it is proper or not. We get the same thing, whatever is here. Next, what we do is we friendships, a data structure we create, empty one, for each of these users, right? 0, 1, 2, 3, 4, 5 till 9. We create an empty list, right? So for 0, this is a way to do it. How we do it? For user in users, right? Every time we get one row, user ID, right? From this user we extract user ID, empty list, right? This is the empty list over here. Next, what we do is we are interested in friendships, right? 0 is with friends with whom all, right? 0 is friends with whom all. We revisit this data structure again. 0 is friends with 1, 0 is friends with 2, right? We are interested in that. The way we do it is, friendship pairs, right? IJ. So it will return a value 0 and 1 in the first case, right? Friendships 0, we append a value 1. For 1, we append a value 0. So this we would have constructed. Next, what we do, again we iterate ij. Next time what we have value 0, 2. For 0, we append 2. For 2, we append 0. This thing. At the end of all iterations, we would have got a friendships list like this. Okay, next, what we are interested in is number of friends, right? Number of friends. 0 is having 2 friends, 1 is having 3 friends, 2 is having 3. So that we are interested in. 0 is having 2, 1 is having 3, 2 is 3. The way to achieve it is like this thing, this code over here. So how the way it happens is for user again, for user in users, we start from here, right? We would get individual items of that user thing, whatever we had here. Every time one row we get, or every time one row we get. Okay, and the way we do it is, okay, user id, right? For we'll give a value 0 till 9. Okay, number of friends for given user. For the friends for a given user, how we calculate it is, right? User id is equal to user id, friendships, right? From this friendships, right, we get friend ids, and then length of that. So when we pass a value 1 over here, 1 over here, right, we will get 3. Length will be 3. So this is this here. 1 is 3 and 2 is 3 and so on. And then what we do is total connections. We are interested in all the connections of all the users. So sum of number of friends for user, but before that, for user in users, right? We get all the values. Okay, sum this. So we sum 2, 3, 3, 3, 2, 3, 2, 2, 3, 1. That is 24. So this value becomes as 24. We assert whether it's 24 or not, and then number of users, right? Number of users is equal to length of users. Length of users is what? 10. Okay, length of users is 10. 24 by 10 is 2.4. We assert here over here, and number of users is equal to 10. We assert. Okay. Next, what we do is once we have this thing over here, we sort this number of friends by ID, but not on the key, but on the value. So what do we get? We get a list with highest number of friends. 1 is having 3 friends, 2 is having 3, and 9 is having least number of friends, that is 1. Okay, so this is the way to do it. This is the way to do. And we again print back friendships, like whatever earlier we had friendships. Okay, what we do in this case is, right, let's say we are interested in friends of friends of value 0, right? So 0 is having 1, 2. 1 is having in turn values these friends, and 2 is having 0, 1, 3, right? So 0, 2, 3 and 0, 1, 3. So this is the thing we are interested in. How do we achieve it? First, what we do is for friend ID in friendships for a given user, right? For a given user, friend ID is this will return a value 1 and 2. This whole thing will return a value 1 and 2. For 1 and 2, right? What do we do is friendships of 1 and 2, right? Friendships of 1 and 2, that will return a value 0, 2, 3, 0, 1, 3. So for ID will have a value 0, 2, 3 and 0, 1, 3. So that is what is here. Next, what we are interested in, like if we are interested in all the FOF IDs of all the users, we just loop over them and we print it over here. So Clive is having these friends, right? And Hicks is having these values. And here what we are doing is from the friendships, we are printing back again 0, 1, 2, right? That values we are printing. Friendships, let's print it again over here. Friendships, friendship data structure, let's print over here. But in this case, we are interested in, let me show it here. Say, for example, for user ID 3, right? User ID 3, like we will get a value 1, 2, 4, but 1 is having a value 0, 2, 3, and 2 is having 0, 1, 3, and 3, 5, right? If we print just 4, 5D, we will get like this. From where we got 0 to 3, we got value 0 to 3 from 1, okay, and 0, 1, 3 from this, and 3, 5 from 4. But like I can't be friend to myself, so I have to drop 3, right? Also, I'm not interested in friends of mine 1 to 4, right? So what I do is my friends are 1 to 4 and I'm not interested in value myself, so we have to drop 1, 2, 3, and 4 from this list. Okay, what all we have to drop? We have to drop 1, 2, 3, and 4. So what we are left out with? 2 zeros, right? 0 occurring 2 times, 5 ones. Okay, the way to achieve it is this code over here. Like the way we do it is like for friend ID in friendships for given user ID 3, that is 1 to 4, right? 4 5D of each of these. 4 5Ds of each of these is 0 to 3, 0, 1, 3, 3, 5, right? We would have got that thing here. If 4 5D is not equal to user ID, first we have to drop 3, and then also we have to drop friends of 3. Okay, this is done over here. So this code, if you loop through, you will get it. Next is yet another data structure is called interest. It means like 0 is interested in Hadoop, 0 is interested in big data, 0 is interested in HBase, 0 is interested in Java. So what is 0? These are all data scientists. Data scientists are 0 is interested from this point till this, right? The way we do it is like we just take this data structure over here, and like we are interested to know who all are interested in Python, right? Who all are interested in Python. The way we do it is for user ID comma user interest in interest, we loop over this, like we get a value user ID and user interest, right? If user interest is equal to target, if it is Python, right, like we return that particular user ID. So for Python, we will get a value 235. Next, what we do is we are interested in user IDs by interest and user interests by user IDs, right? Say for example, we want to know what all 0 is interested in, and we also want to know uh, interests for given user ID 0. Let's say, okay. So the way we construct it is like empty default dictionaries. Two empty default dictionaries we like initialize, and the way we do it is like user ID user ID comma interest in interests, right? We append for this like this interest over here and this user ID over here. So when we loop through this, and when we loop through this, we will get two data structures like this, right? So Hadoop, who all are interested in Hadoop, 0 and 9, and 0 is interested in all these. You trace the code, you will get it. Next is like we are interested in most common interests, okay, like with user a given user. So let's say we are interested in most common interests with user 3. User 3 is this, right? User 3 is this, okay. Now what we do is like for every value of this, for every value is R, Python, statistics, regression, probability, we revisit this data structure over here. For R, right, for R, let's say 3 and 5, right? 3 and 5, 3 and 5, but 3 is self, right? 3 is self, we have to drop that, we will get a value 5, okay. Next, Python, visit Python over here, 2, 3, 5, 3 is self, so 2 and 5, 2 and 5, right? Next, statistics 3 and 6, 3 is self, drop 3, 6, that is 6, right? Next, what we have, regression, if you revisit 3, 4, drop 3, 4, 4, and then last is probability, if you revisit here, probability, where is, yeah, 3 6 3, you drop 6, right? So this is 6. So now you construct a dictionary with these written values, right? So what will happen? 5 will appear 2 times, okay, 6 will appear 2 times, 5 will appear, sorry, 5 we have already done. 2 will appear 1 times, 4 will appear 1 times. But what it means is, okay, 3 shares, 2 interests with 5, 3 shares, 2 interests with 6, 3 shares, 1 interest with 2, 3 shares, 1 interest with 4. Let's check it. One value will take, let's say, 5, let's take 3 and 5, okay. 3 and 5, if you see, R and Python is common. R and Python is common between 3 and 5. So 3 and 5 have 2 values. So you trace it, you will get it. I just showed you the way. Now let's say salaries and tenures, like yet another data structure we create, salaries and tenures. Now this is a unique data structure, like, where for 8.7 years this is salary, 8.1 years this is salary, and things like that. That's the meaning of this. So salary by tenure, default dictionary, again we empty dictionary we create, and for salary tenure, in salaries and tenure, we loop over all these list items, right? List items, and what we do is we go on appending salary for tenure. Okay, so if you, at the end of it, if you just print, let's say, salary by tenure, you'll get a data structure like this. And like what we do is, of course, in each of these lists there is only one item. Had there been multiple items, if we take average, this would have been meaningful, but here, since there are only one values, we will get back the same thing here. Okay, so that is done over here. How it is done? For tenure salaries, in salaries by tenure items, individual items, tenure colon sum of salaries divided by length of salaries. This is the way we construct this data structure. So that is printed over here. And next is, like, yeah, tenure bracket. If tenure is less than 2 years, we print less than 2 years. If it is less than 5 years and higher than 2, we say between 2 and 5. Else we say more than 5. So like, again we create a empty salary by tenure bucket, and then like the way we do it is, for salary and tenure, in salaries tenures, right, we loop over this. Bucket is equal to tenure underscore bucket tenure. So tenure is what? Tenure is, like, one of these things, right? One of these things. We create a bucket, and then in that salary by tenure bucket, for each of these strings, we go on appending salary. Okay, we go on appending salary. So just when we print salary by tenure bucket, right, we will get like this: more than 5, this is more than 5, these values; less than 2, these values; between 2, these values. And then if we average out these values, we get over here. And that is same what we did previously. Next is, like, interest data structure we are reprinting here. Only thing is, space is chopped off here. This is big data. Now what we do is, like, we create a dictionary counter. How we create it? For user interests in interests, right? We loop for each of these items, and then for word in interest lower, right? Like, we go on getting values, Hadoop, big data, and things like that. Okay, we create counter, a dictionary item counter with those values. So, like, how many times Java would have appeared? Java would have appeared 3 times, right? And Python would have appeared 3 times. So this counter, when we print a counter, right? Okay, when we print this counter, we will get this value over here. Okay. Now what we are doing is, like there is a function over here, most common. For word and counts, most common we are taking. If it is greater than 1, if it is greater than 1, we are printing word and count. So you get a value over here. Yeah, this was a chapter on introduction to Python. Don't get discouraged, and don't be overwhelmed. If some of the things in this chapter you didn't get it, it's fine. You will pick the momentum as you proceed. Okay. Welcome to chapter on data visualization using Python. So we are making use of work of the author of the text prescribed textbook. So first, what we do is we plot a very simple graph where it is for nominal GDP, and we have a list with years 1950, 60, 70, 80, 90, 2000, 2010, and the corresponding GDP for them, right? So here there are 7 items, right? 4 plus 3, 7. You have 7 items in GDP. We just make use of pie plot. We make use of pie plot and plot this list and GDP. So, when you plot this, for this value, X value, this is a Y. Okay. So first value we get it here. For next one, for 1960, 543.3. 543.3. So we go on plotting it. How? Color we want it in green, and marker should be O, a round circle, and line style should be solid, meaning all these points should be joined using a solid line. And we put a title as nominal GDP, that comes over here. And Y label, we print billions of dollars, billions of dollars. So plot dot show, when you say, you will get a plot like this. Next is see, for 5 movies are there, and how many Oscars those movies got. Annie Hall got 5, Ben Hur got 11, Casablanca got 3, and so on and so forth. What we do is, right, in this case we just did a plot, right? We just did a plot, but in this case we are interested in bar plots. So when you say plot dot bar, okay, and range of length of movies is 5. Okay, this is 5. And number of Oscars is 5, 11, 3, 8, and 10. Okay, you when you plot this, you get this, and then you title it with saying my favorite movies. Okay, and Y label number of Academy Awards, and X is this. Okay, X is this. How many? 5. With what? With these values. Any Hall, Ben Hur, Casablanca, Gandhi, West Side Story, you print it over here. However, if you have lot of data, this area may not be sufficient. You go for horizontal plots. In that case, what you do is, whatever you did here, bar, right? You just say bar H. Everything is more or less same. Everything else is more or less okay. And the way you do it is, right? Movies, number of Oscars, okay, movies and Oscar, number of Oscars, bar H, horizontal. H stands for horizontal. A title, X label, in this case X label, number of Academy Awards, because Y text will be movies in this case. West Side Story, Gandhi, Casablanca, Ben Hur, and Annie Hall, right? So you will find this horizontal bars more useful when the data is too much. Next is we are plotting histograms, right? Histograms. We already have grades for one exam, let's say one exam, 83, 95, 91, and so on and so forth till 0. And the way we do it is we create a dictionary. Counter already you have understood from chapter 1. It's a dictionary, right? It's a dictionary. And what we do is, for grade in grades, right? We go on getting value 83, 95, 91, 87, and so on and so forth till 0. Okay, that will be the grade, individual values. And minimum of grade of floor 10, star 10, 90. This is to handle a case when the value is more than 90. When the value is more than 90, we round it to 90. So this hack over here is to bring it back to 90. Okay, we print histogram for taking the value. So 80 is having 4. Okay, and because it is having 4, 83, 87, 85, 82, 4, right? 90, 90 is having value 3, 91, 95, and 100 is also rounded to 90. So 3, you trace it, 73, 02, 61. And the way we plot it is plot bar. We again plot bar. Okay. And how we do it? Histogram keys. Histogram is a counter over here. So we go on getting value 80, 90, 70, 0, and 60, right? We go on getting those values. Histogram values will be 4, 3, 3, 2, 1, right? Histogram values. And 10, give each bar a width of 8, right? This is to make sure the bar is of a certain width, and edge color we are making it black over here. This edge color black. Okay, and this plot axis minus 505 0 5, right? Minus 5, okay, 0 minus 5, okay, 105 from this till this point 105, and 0 and 5, okay, 0 till 5. So you are explicitly setting the boundary for this graph, and x is, right, like stick is I in range 11. So this will give a value 0 till 10. So that value you take and multiply it with 10 each time. So x picks you go on putting at this places. Okay. And then you go on putting at that particular values. And x label this decile. Okay. Y label number of students, distribution of exam grades 1. So that value you print, you get a bar chart over here. Histogram over here, which is nothing but a bar chart. And then if we are interested in a scatter plot, let's say, for x, A is having x coordinate 70, y coordinate 175. We already have 3 lists corresponding to them. G is having x coordinate 105, y coordinate 60. So the way we do it is, we call plot scatter. And we pass friends and minutes, this and this list. Okay, and we have to print the labels. For that we make use of annotate. And the way we do it is zip, right? A zip function you would have encountered in your Python studies. Whenever you pass labels, okay, friends and minutes, right, it will give a value A. 70 and 175 is the first tuple, right? First tuple, and you iterate over each one of them, and you annotate with labels, right? What label? Label you pick it from this list A. So you go on printing A, B, and all the values C and D. You go on printing all the values. And plot title you just say daily minutes versus number of friends. Okay, X label as number of friends, Y label as daily time spent on site, right, on the site, and plot.show. So here to quickly recap, 3 lists were there. You plot a scatter plot with these 2, right, and then you annotate each point with appropriate label. Okay. Next is a case where we have two lists. You plot a scatter plot, but in this case, matplotlib decides the width and height. Right? If you see, it has magnified from 80 to 97.5, approximately 18. Right? If you subtract 80 from this 18, it has plotted in this big area, and 100 it has plotted in this much area. But if you want to control, let's say, the resolution, if you want a equal, x and equal y, you can do like this, right? You just say axis equal. When you say axis equal, You see here, this is also 60 to 100, approximately 60 to 110. This is 60 to 100. So this, like in a small area, like it has printed these many dots. But if you see here, this is more visualizable. So that is the example over here. So this was a brief introduction to Matplotlib. I want to show you a few more things. So see, Matplotlib, if you go visit this matplotlib.org, right, you will find something called examples. If you click on this, you will get a lot of examples. Go through each of them. They will help you. They will definitely help you. And in addition to that, we make use of CBOR, which is more for statistics, statistics data visualization, as it says over here. So for each, like each of this, you will get gallery, like how to install it, and examples also you will get multiple examples you will get for CBOR. CBOR also we make use of, and yet another modern library is Plotly. Like if you say plotly.com Python, you will get examples over here. These examples also you can check. Out of this particular interest for me is Python Express Plotly Express. So this abstracts out many lower level details, and you can plot a very powerful graphs with Plotly Express. Okay, so that was a quick chapter on visualization using Python. I think you would have enjoyed this particular chapter because it was not so elaborated as chapter on introduction. Thank you.